Hello, guys. We need to do something. Before we continue integration last week we did partial fraction integration, trig integration, some typical integrations, right? Before that, we need to check differentiation. In differentiation, you learn a lot of rules, right? Like a product rule, quotient rule, those rules.
First question was quotient.
Check quotient rule is in the formula sheet. Yeah. Okay. We did more differentiation. Question 1. E to the power of x differentiate. What's that? Question 2. 3 to the power of x differentiate. What's that? Question 3. X to the power of x differentiate. What's that? Or maybe we check a to the power of x. Question 4. What's x to the power of x differentiate? It's weird, right? Yeah, we need to check some question. Weird question. The first one. Yonghua. Good. How about the second one? Who can guess the second one?
3.
Oh, 3 to the power of x is almost perfect. We need to times the number. Let's have a look. Guys, we need yeah, everyone is correct.
Actually.
Yeah.
Whoa, so smart. Wait, why?
Why?
Thank you, bro. Well, it has to work with the e.
Yeah.
Oh, Lenny.
We got the 2 ways here, guys. We got 2 ways. The first way. 2 ways. Check. The first way. Understand this step? What I just did, I just logged both sides, right? Next step. Do you understand this step?
Yes.
Now, let's do implicit differentiation. Yonghua, your neighbor's name?
Sarun.
Oh, yeah. Can you? Implicit.
1 over y, dy, dx.
Excellent.
Whoa.
The other side. Oh, because this area 3 just a number. It's very same as 4x differentiate just 4. So area 3. That's why dy dx equals y ln 3. Hello? That's why Aaron correct. Yeah. If you memorize it, that would be a formula. Yeah. Because we try to move the power to from. For example, this one. If you still do y equals ax, and then you ln both sides, Cameron, what do we have? If you ln both sides or log both sides.
You get x ln.
Very good. Now, Cameron, if we differentiate using the idea about implicit, what you have?
You get 1 over y, dy dx.
Yeah.
Ln.
Very good. So dy dx just equals y ln a. But y is right here.
So
Ax ln a. Okay. Guys, try number 4. Hurry up. Try number 4.
Is it the same thing?
Yeah, I do the same. Number 4. Number 4. Number 4.
I'm a 4.
Number 4,
Mr. Snakehead.
So are you doing number 4?
This is how.
Wow. Number 4, like A, B, C?
Yeah.
That's something that's
X to the X.
Oh,
God.
That's
Wow.
what I
Oh my god.
Hey, shut up. No one is there.
It's X to the X and then X.
Oh, I want to know
It's probably. I think this is.
Wait, does it dash? I thought it was a wait, does it dash as a sun?
Oh, you're ruined for a while there.
I actually didn't realize it was
Why? Just Big Ten.
Oh, power of one.
That's
what I think about actually. That's so small.
Literally, that's what it did at the end.
You know, Cameron lost to a girl game.
Emily.
Lost to a girl game. Yeah.
She was playing Teemo. What the hell do we do? She was playing Teemo. She was playing Teemo.
Unlucky.
Dude, I can't even get close to her. Especially as Aurelia. What you gonna do?
He's the best of the characters in the world.
That was no. That was if I was on your team. I would have carried you because I like you,
That's all thing.
bruh.
Yeah, you're right.
Like,
I got you.
I'm like over here, and she's like over here, and then she presses Q, and it goes like, boom, I can't hit anything. And then,
Right,
like,
good answer.
oh my god.
I think I got the answer.
X Linux. X. Oh my god. This one,
Differentiate.
we were in my friend's car, and we were blasting Rip Roach. My ex did a touch him, and it was so loud. His car broke.
No, that's not
Yes, I know.
No, that's not. I don't want to fail.
That's what I said.
This guy's the guy who does more. That's the Indian remix.
Hello.
I
got that.
This guy was so like
unnecessarily
Not even funny.
No, he just wasn't funny.
Wait, what is this?
I was cringing about this.
If it was
What is it?
it wasn't
Why do you
great.
give me Bro, that whole presentation is supposed to show how.
We counted 82 cringe moments and 120.
We also didn't really tell us anything new. Like, obviously, we have to do something we're passionate about.
That's 0.68.
Oh, fucking check.
Why is
Oh,
it
fucking shit.
Why
This guy got a second.
Why did you be like
Yeah, there was a
Why
cringe
they-
every 2 minutes.
Joe?
If it was in real life, it
No,
Yeah.
that would happen in real life. Just how trash that would be in real life.
People were like laughing a lot.
No, that happened last year.
Wait, what's the talk on?
They did it, no.
Okay.
The year before.
What up, big dude?
Where did they get these people from? Like, do they find
Wait,
it?
wait, wait.
Like,
Which guy? Which guy?
If you finish this, of course you can check the document I gave you. The several pages I gave you, which is for integration. So the idea here, y equals xx, ln y just x, ln x. If you differentiate 1 over y dy dx. Camera on the other side.
Does it do product rule?
Yeah. 1 times ln x
I got
plus,
ln x plus x over x. So just
yeah, ln x plus 1.
yeah.
So dy dx just equals xx ln x plus xx.
I don't know.
Wait, what? Wait.
Oh, you times y.
Oh yeah.
Okay. This question,
I'm right.
scholarship exam question.
Really, that's very easy. You just need to know what he's doing.
Yeah,
There's no way that's scholarship. That was easier than the
Oh
test
yeah,
script.
one part. Guys, I'll design a question. You can have a look on.
It was like harder than today's test. Right? Easier than today's test. Oh, I love this one. Makes me cry.
Every time I know.
How you differentiate this one? Hurry up.
Can you do the Lin again?
Yeah. Hurry up. Differentiate this one. Where is Howard?
He didn't come to school today.
He wagged.
It's playing games right now.
Oh.
Yeah, those one, please.
Wait, let's call Howard on Discord right now.
It's cool as well.
Just call Howard on Discord. Be like, what should we do?
Okay. Just check the question. idea same，就是 ln y tan x ln sin x. Oh, if you differentiate 1 over y dy dx, if you differentiate tan x, what you have? 6 square x plus 10x times 1 over sine cos x.
Wait, what?
I'm so small.
You even know how to do it.
Sec-
Thinking of.
Yeah, how did you get plus sine?
Oh, you just move y to the other side. I just didn't write that step. Okay, I'll write one more step.
Oh, you just times it, right?
Yeah.
How did you get 10 of 12? Oh, this sine. Is it 10 times 1 over sine?
Yeah. 10 times 1 over sine.
Oh, you wrote it wrong on the bottom one, on the second one.
Sine.
Wait, so
Oh. God damn it, you're such a child. And then I was like, oh, if you don't understand something like this, you can ask me about it. Oh, yeah. Have you checked the third one? So I was really excited.
Okay.
Is that the answer? No, that's the end of the answer. That's what.
I better tell you the idea here. We proved the formula, but what's the meaning of this type of differentiation? What's the meaning of? Check here. We recheck this question. X bar of x is based on two formula. X to the power of n, a to the power of x. If you do x to the power of n differentiation, you move n to front, the power minus 1. Okay? If you use this formula, that's another formula, right? So you got x, ln x. Check the idea out. If you pretend the power is a constant, if you pretend this power is a constant, you just move the power to front and then power minus 1. If you pretend the base is constant, we just copy the function, we times by ln the base. Okay, you pretend on, or you consider. If you consider the power is constant, we need a here. If the base is constant, we have here. Okay. The similar idea happened here. Fx times gx differentiate. If gx constant, you just got f dash g. If gx constant, if fx constant, we just differentiate g. Okay, when you treat one part constant, you differentiate the other part. And finally, you plus them together. For this question, we plus these two together. Have a look what happened. If you plus these two together, you really just got here. Same answer. If you treat one part constant, keep it, you differentiate other part. That's the idea. That's the idea. This idea pretty important. When you differentiate something, okay? We can differentiate one part, keep the other part no change. Okay? Okay 啊。Okay, let's do integration now. More integration.